Hi, this is chapter 2, day 1, and this is the study of z-scores. Okay, z-scores are the most basic, fundamental thing in all of statistics. This is the factoring of statistics. This is the trig wheel of statistics. Z-scores is so basic. It involves the mean and it involves the standard deviation, the two most powerful statistics that we deal with, okay? And a z-score is simply how many standard deviations are you above the mean or below the mean. If you are above the mean, you have a positive z-score. If you are below the mean, you have a negative z-score. If you are at the mean, your z-score is 0. And this stuff is used for normal curves in general. So, real quick, density curves. A density curve is any curve that has an area of 1, no matter what the shape. We're going to deal with normal curves today, but any of these shapes has an area of 1. And what is a density curve? A density curve is essentially data taken from a histogram, okay? You get a histogram, and then you put a smooth curve around it and basically make it equal to 1. Make it all percentages, from counts to percentages. It has an area of 1, okay? All right, so key features. A density curve shows the distribution and has an area of 1. I've told you that. Now, remember all of these from the previous video lesson that we had. The big 4 in shapes, okay, are uniform, symmetric. Symmetric is often thought of as a normal curve, skewed left and skewed right. So there's normal right there. You can have different types of symmetric. For example, this could be considered symmetric right here. It's also bimodal because it folds onto itself, so it's symmetric, okay? So if you remember all those, if you recall all of that. Okay, now for the most part, we're going to be using what's called z-scores. And z-score is called a standard score because it is how many standard deviations you are above or below the mean. Positive is above the mean. Negative is below the mean. 0 is at the mean. Okay? All right, and here is the calculation. It's an individual number, x sub I, minus x bar, which is the mean, divided by the standard deviation. So whatever number you have, subtract the middle or the mean and divide it by the standard deviation. Okay? So let's go through these 3. You can see the answers, and again, like I always say, pause the video at any time so you can practice these numbers. Okay, so let's say on item A here, we have a score of 77, a mean of 71, and a standard deviation of 3. Okay, so the score would be 77. We're going to subtract the mean, which is 71, and we're going to divide by the standard deviation of 3. The answer, of course, is 2, because you are 2 standard deviations from the mean when you are at 77. Okay? For this one, your score was, I'm going to put this right up here. Your score was 18.3 and the mean was that. So we got 18.3, subtract the mean of 19.5, and that's going to come out negative, and divide by 0.4. And that comes out negative 3, meaning you are 3 standard deviations below the mean. Okay, so that's almost an outlier. It's pretty far down in the tail of the distribution. Okay, and you can do the other ones very, very easily. Notice this notation means normal curve. Normal curve. It's one of these guys right here. A normal curve with a mean of 12 and a standard deviation of 2. So how this would go would be 9 minus 12 divided by 2. And of course that answer is negative 1.5. Okay? And you can walk yourself through all the other ones if you would like. You can stop the video here probably and check those out. Okay? All right. So let me move on to the next thing. Now this next part is we're going to be using tables or calculators. You'll probably love your calculator, but tables or calculators to figure out the percentage or the percentile rank using z-scores, okay? So you have these curves, and for right now, you want to write all this down on your notes. And it's very encyclopedia-esque, so you want to probably stop the video and write all this down. I'm going to show you how to find the area under a curve if we use a table or a calculator. The tables are located in the back of your books. They're often called Table A. I know on the AP Statistics formula sheets they're called Table A. Okay? So go ahead and write this down and use it for a reference later if you need it. Okay? And I'm going to move on now to part 3 right here, 3A, through doing the ones on the table and on the calculator as well. Okay? Okay, now we're going to start using the tables and the calculators. Tables on this side, calculators here, to figure out what z-score corresponds to what percentile rank, what area under that curve, which has a total of 1. So let me give you a sense of what's going on with this curve, okay? In a normal curve, let me change colors here. In a normal curve, all right? In a normal curve, 0 is the 50th percentile, meaning 50% is above 0, 50% is below 0. If your z-score is 0, you are the mean, okay? A z-score of 1 is actually the 84th percentile, okay? A z-score of 2 is really far in the tail. It's about the 97th percentile, and a z-score of 3 is about the 99th percentile. A z-score of -1 is the 16th percentile. A z-score of -2 is about the 3rd percentile, and a z-score of -3 is below the 1st percentile. So on this problem, a z-score of 0.8, 0.8 is right about here. It's not quite 1. And so if you shade the area below it to give you a sense of that, you probably realize that that's well over 50% of the data in there. Okay, z-score of 1. So it's the area below that. So area below 0.8, I colored a little bit too far there. There we go, right about there. Okay, and the answer, as you can see, is 0.7881. Let me show you how to get that on the calculator. Okay, let me show you how to get that on the calculator. All right. Excuse me. Let me show you how to get that not on the calculator, but on the formula sheet. My bad. Formula sheet. Okay, so I'm going to slide this sheet up a little bit, okay? There we go. Now what you got here, I left the curve there for you, is the z-score table. There's a positive sheet and a negative sheet. And what you have is, this is the 10th spot and this is the 100th spot. And z-scores are always rounded to 2 spots per tradition. It's not like significant figures. Just tradition. So 0.8 is 0.80. 0.8 in the 10th spot, 0 in the 100th spot, 0.80, there it is, 0.7881, exactly as we thought it would be. Okay? So let me go back and do a couple more of these problems for you, all right? Okay, question B. Question B has a number greater than negative 1.32. So let's get a little drawing of this. Okay, negative 1.32. Remember, the middle z-score is 0. Okay, negative 1.32 is right about there, 1.32. It's pretty far in the tail, actually. And we want the area above that, So I'm going to shade this so you get a sense of it. The area above that. And shading is something we'll do quite a bit in this course. Okay, area above that. All right, now the table is only going to give you the area below that. So I'm going to get the area below that, and because this thing equals 1, I'm going to go 1 minus that area, and I'm going to get the answer. So let me flip over to the negative z-score table, and we're going to find negative 1.32. Okay, so here we go. There's negative 1.3, and you're going to slide over to 2. Negative 1.32. And there it is, 0.0934. 0.0934 is this area right there, okay? And if I go 1 minus that area, I will have my answer, okay? So those are the two types of problems you're going to do. You're going to find the area below 1 or above, and it'll depend if you take the number straight up or go 1 minus, depending on if it's less than or greater than. So let that be your guide. Okay. So here are the answers to these particular problems, okay? So this one is a 1 minus problem because it's the area above it. This is just the area below the number on the table. This is a 1 minus problem because it's going to be the area above it. This is just the area off the table. Now, these are a little different. Let me do one of these for you. Okay, item G here. We want the area between 0.3 and 1.8. No problem. So let me draw a curve. Take up some space here. So 0 is the middle. 0.3 right about here. 1.8 pretty deep in the tail. 1.8. And I'm going to shade that area so you get a sense of what that is, okay? And you can see the answer is sitting there for you. And the answer is about 1/3, 0.3462. That looks pretty good. Maybe I should have drawn it a little bit bigger, but you pretty much got it. So what we're going to do is we're going to find the area below 1.8. See my pen? 1.8. And we're going to subtract the area behind 0.3, and that will leave us with this. Once again, get the area below 1.8, subtract the area below 0.3, and that'll leave us with that particular area, okay? So let me go over to the formula sheet and get that. Okay. So here's 1.80 right here. 1.80. 0.9641. And then here's 0.3. 0.6179. And if you subtract that, you will get the area between here, which was about 34% if I'm not mistaken. Again, 0.9641 is the area from 0.1, 0.8 all the way down to the bottom. 0.3 is this number, 0.6179, is from 0.3 all the way to the bottom. And if we subtract those, we're going to be left with that area. That's how you get that answer. Okay, I'm going to flip back over to that. You should probably pause the video and work out the problems by yourself and check your answers. Okay, So pause here and work on all these ones to make sure you got it dialed in. Once you have that, restart it. Then I'm going to do the other side of the page, which is how to do these problems with a calculator. Okay, with a calculator, this won't be too difficult with the calculator. What you're going to do is you're going to draw the picture out. We want the area below -2. All right, we know -2 is really far in the tail, -2. We want the area all the way down to the bottom. So again, I'm going to shade that for you so you get a sense of what that is. There's the area below that, okay? And I'm going to call this area below -2 negative infinity, okay? Now on your calculator, you don't have to type in negative infinity. You can just type in like -1,000. It's probably far enough to get all the way to the end of the tail. In theory, this tail never ends. It goes on forever, okay? It's a limit, one of those calculus things, okay? So on the calculator, follow me on this. You're going to type in two numbers. We're going to go to something called normal CDF. This stands for cumulative distribution function. Normal cumulative distribution function. And I'm going to type in two numbers. My calculator may have 4, and I'll explain that in a minute. Okay? You're going to type in -1,000, meaning that's the end of the curve, and then -2, okay? And you always type in the left bound of the shaded area, then the right bound of the shaded area, okay? So I'm gonna go ahead and do this problem, and we're gonna get this answer, okay? So let me clear this, and then I'll go to the calculator. Okay, on the calculator, I'm going to go second vars, which is the distribution button. Second vars. And I'm going to go to normal CDF. We actually never use normal PDF. I'm not even sure where they have it. Normal CDF. And I'm going to type, this is actually negative infinity. I'm going to go ahead and type in -1,000. And by the way, for the negative button, you have to use the minus button below the 3. And the upper bound of that shaded area was -2. Now, my calculator has 0, 1 on it, meaning this is the standard normal curve with the average z-score being 0 and the standard deviation being 1. Your calculator probably just allows you to put two numbers in, probably. Okay, I'm gonna hit paste. So on your calculator, you'll probably just type in -1,000, -2 and be done. But you might have this. And you get that, and there it is. Round to 4 spots. The reason we round to 4 spots is because that's mathematical tradition, so that a kid using the table will get the same answer as someone using a calculator. So that's 0.0228. Okay? All right, let's go over the next question. Okay, the next question. All right, the next question, I'm not even going to bother using the calculator, okay? This is the area above 0. We know 0 is the middle z-score. And so if you shade that in, the area above that, it's going to be 50%, 0.5000. That's easy. I wouldn't use a calculator. I wouldn't use a table. I would use common sense, okay? All right, next. The next one there. I want the area below below 1.3. All right, so let me draw it out. 1.3, I know that 1 is the 84th percentile, so 1.3 is getting pretty far on the tail. And I'm going to shade that area like I've been doing to help you see it. The area below 1.3, okay? So when I do this, I'm going to type in on my calculator NCDF left, right. The left bound shaded area is infinity, negative 1,000. And the right bound is 1.3. That's probably the two numbers you're going to use on your calculator and put a parentheses and hit enter. Sometimes there's a four function part or four number part where they want 0, 1, meaning you're dealing with the standard normal curve of mean of 0, standard deviation 1. That's what mine does, okay? So I'm gonna get this answer, okay? So let's go over to the calculator, okay? Okay, second distribution, NCDF. And I'm going to type in, I'm going to leave my infinity of negative 1,000, and I'm going to put 1.3. And I'm going to leave 0, 1, because that's the standard normal curve. And I'm going to get 0.9032. And again, I'm going to round to 4 spots to match the table that's provided, 0.9032. Okay? All right. The next problem is a z-score less than 0.25. 0.25 is a fractional z-score just above 0. So let me draw this out. Just above 0. Okay? 0.25 right in here. 0.25 right next to it. And I want the area below it, once again, below. So the area below, you know the answer is over 50%. And of course, you can see the answer right here is 0.5987. You can see that. So I'm going to go ahead and put this on the calculator as well. Okay, so there it is all shaded in. So on the calculator, second distribution NCDF, I'm going to type in negative infinity, comma, 0.25. And I'm going to leave my calculator the standard normal of 0, 1. And again, round to 4 spots, because that matches the table, 0.5987. Okay? All right, the next one, we're finally going to do one that's a little bit different. This is the area above negative 1.48. Above negative 1.48. Okay? So I'm going to draw it out just to get a sense of it. Okay? Negative 1.48 is pretty far in the table. Negative 1.48. Pretty far down. I want the area above that. Okay? So the area above that is pretty far. It's a lot of area there. Okay? That's almost the whole curve. It's over 90%. And you can obviously see the answer. Okay? So in this case, the left bound of the shaded area is negative 1.48. The right bound is positive infinity. Left, right. So NCDF, negative 1.48, comma, infinity. And I'm going to use 1,000 for positive infinity. So left, right. Left shaded area, right shaded area. Okay, so let's go to the calculator to figure this out. Okay, second distribution, NCDF, negative 1.48 is my lower bound or left bound, and my upper bound now is positive infinity, which I'm going to just use 1,000. And there's my answer, 0.9306, rounded to 4 spots. Okay? All right. Now, let's handle one that's a little bit different. How about Q right here, where we are between two z-scores? This is really easy. Between two z-scores. Again, let's draw it out, okay? 1.3 is sort of in the tail there, 1.3. 0.32, right? Zero's the middle. 0.32 is right next to it right there, 0.32. So the shaded area in this case is fairly small. That's the shaded area, okay? So we want between 1.3 and 0.32. There we go, right about there. Okay, so what I'm going to do in this case is I'm going to type on my calculator the lower bound or left bound area, which is 0.32, comma, and then the right bound is 1.3. Okay? Left bound, right bound, 0.32, 1.3. So let me go to the calculator and figure that one out. Second distribution in CDF. I'm going to type in 0.32 for my lower bound or left bound as I once learned it. And my upper bound is 1.3, yeah. All right, and then I'm going to go ahead and paste on mine. And there's your answer. Round it to 4 spots. 0.2777 will be the answer. Okay. I'm now going to put up the rest of the problems, and you should try to work them out on your own. Feel free to pause the video if you need to, but I'll leave it there so you can work out the rest of those with the table or the calculator. Okay, now, this is one of the basics of, I have a really good system to now do the word problems that we're going to be doing. When we do these problems, we're going to have 3 levels. We're going to have the raw score, the z-score, and the percentile. What you're doing in z-score normal calculation work is you're just changing units. It's sort of like inches, feet, yards. I'm sure there's other conversions you have in sciences from moles to whatever. Okay, you got all kinds of stuff. But in statistics, we have the raw score from the actual problem. Then you have a z-score, so you can put it on a standard scale. And then you have the percentile. The reason in general z-scores are so important is that it helps us compare things that are on different scales. So, as you know, the SAT is out of 1600, while the ACT is out of 36. Well, if you score a 1100 on the SAT and a 28 on the ACT, how do you compare those? Well, you compare them by finding the standard deviation out of each one of those. Then what you do is you put them on those scales and do a percentile rank. So that way you can tell which one was actually higher. That's the purpose of a z-score, percentile ranks, is to get a common scale. Okay, so I tell the kids all the time to write out 3 levels, raw score, z-score, percentile. So that way we know exactly how to handle this, okay? So our procedure for solving these problems will be as follows. Sketch the normal curve. Label the mean. Label the standard deviation. By the way, the standard deviation label goes out to the first deviation, which is the 84th percentile, okay? create a row for raw data, create a row for z-scores, and create a row for percentile. And then we're going to do all of our conversions using our table, calculator, etc. This is going to be super easy. Okay? All right, let's do 4A and 4B together. The mean test score for a class of 81 with a standard deviation of 8. Find the percentile rank of someone who scored a 92. First step, label the mean, 81, label the standard deviation, 8. Then go ahead and estimate where 92 would go, okay? And I'm going to do a quick calculation of the z-score for 92. And I'm going to put that right here. Z equals 92 minus 81 divided by 8. Whoops. Okay. Let's try that again. Going crazy on me. Okay, so Z equals 92 minus 81 divided by 8. And as you can tell, that's this answer right here, 1.38. So I know that 1.38 is past the first deviations, past that. So I put it down here. I'm going to shade in this because percentile rank, by definition, is how many people are at or below you. At or below you. And now what I got to do is I got to convert 1.38 to a percentile rank. And you can do that one of two ways, on the table or on the calculator. Now I did the calculator earlier in here, so what I want you to do is see if you can get this. You're going to type in NCDF, and you're going to type in negative infinity or 1,000, and then the z-score that you have, 1.38. Okay? Lower bound, upper bound of the shaded area, or left bound, right bound, if you want to do it that way. Okay? And then you'll get your answer of 0.9162. No problem. Now, this problem is here to show you the relationship. What's the percentile rank of someone who scored a 70? Step one, label the mean. Label the standard deviation to the first standard deviation mark, which is the 84th percentile. That's the 50th, that's the 84th. And then 70, I'm going to get the z-score for 70. 70 minus 81 divided by 8. And that comes out negative 1.38. Notice that one was 1.38 and this is negative 1.38 because 70 and 92 are both the same distance from 81. They are 1.38 deviations from 81. One is negative and one is positive. And again, when you type this in of the shaded area, I'm going to go ahead and shade this so you understand it, of the shaded area. That's a pretty small area. And I'm going to write down my calculator keystrokes, NCDF negative infinity or negative 100, comma, negative 1.38. And I get my answer of 0.0838. Notice that 0.0838 and 0.9162 add to 1 because of the fact that this piece is the exact piece that's here. It's just on the other side. I just wanted to show you the symmetric quality of that with these two questions. Okay? Now we're going to go on to C and D right now. Okay? Again, feel free to pause this at any time. Okay, for C and D, I'm just going to do C and then I'll let you a chance to try to figure out D. For C, the mean height of a La Quinta girl is 64 inches, 5'4", with a standard deviation of 2.5. Find the percentile rank of a La Quinta girl who measures 72 inches tall. That's a 6 foot tall girl. So she's going to be really, really high. We already have the answer here of 0.9993. Okay, first step, raw score, z-score, percentile. We're going to convert 72 to a raw score, to a z-score, and then to a percentile. From a raw to a z to a percentile. So I'm going to go 72 minus 64 divided by 2.5. Okay, that's my z-score. I'm going to label that. And that's going to be 3.2. Now on your calculator, you're going to go NCDF, and you're going to go negative infinity, or around 1,000, comma, 3.2. And remember, 3.2 is very, very deep in the tail. 3 is almost the max. It's very deep in the tail, okay? And again, let me shade that area so you have a sense of this. Okay, here's the shaded area, okay? So this is why this is the left bound and this is the right bound. And then there is your answer, 0.9993. All right? And so go ahead and work on this problem and see if you can get a percentile rank of 62 inches for a 5'2" girl, a little shorter than the average. See if you can get 0.2119. There's your z-score, negative 0.8, and there's your percentile rank. See if you can get that, okay? Okay, E and F, I will not be calculating, but I will let you try to work these out. Again, these are all percentile ranks, so it's the area below them. So let me go ahead and at least shade these for you. It'll be this area here and this whole area here, okay? So pause the video and work on those and see if you can get the two answers of 0.0367 and 0.9838. Okay, for G and H, we're going to be going backwards. And this is going to involve an inverse function on your calculator, okay? So the mean SAT verbal was 496 in 2013 with the standard deviation of 120. Jake's verbal score was at the 65th percentile, okay? What was his verbal score? Okay, step one of all this is, if you can remember this, step one, label the mean, label the standard deviation. The 65th percentile actually probably right about here, okay? The 65th percentile, this would be the 84th, so it's right a little closer in here. 65th percentile, okay? So I'm gonna label 0.65. This is what I know. I know this, and I know 120. I don't know these two numbers yet. So what I'm going to do is I'm going to convert 0.65. I'm going to go backwards. Going backwards is called the inverse. I'm going to go backwards, and I'm going to change the percentile rank into a z-score. That's an inverse function. And let me show you how to do that on the calculator, okay? All right, so 65% into a z-score will go like this. Second distribution, and you're going to go down to inverse norm. Second distribution, inverse norm. Makes sense. Going backwards, inverse. And you're going to type in the area as 0.65. On most calculators, that's all you're going to need. On this particular calculator, it still wants to know, are you in the normal curve? Yes, the normal curve has a mean of 0. and a standard deviation of 1. Okay? Once you have that, it'll give you the z-score. And I'm going to round that z-score to 2 spots, 0.39, because that matches the tables, 0.39. Okay? All right. So that is how I converted from here to here. Okay? Now, to keep going to get the answer, I'm going to use my little formula. And that was the z-score, which is 0.39 now, equals, this number I don't know yet. It's going to be x. I'm going to subtract the mean, and I'm going to divide it by the standard deviation. And if you work that algebraically, go 0.39 times 120 plus 496, you will get 542.8. So this is how to do a problem with the inverse. Okay? All right, the next one. What must Jake score to be in the 75th percentile? So again, I mislabeled this a little bit. This is the 84th, 1 deviation away. So the 75th is probably right about here, right about there, 75th percentile. The 75th percentile is you were better than 75% of everybody. Okay, so that's that shaded area. Okay? No, so we know this number, 496. We know 120, and we know the 75th percentile. We do not know the z-score of this yet. We're going to go backwards. The inverse is going backwards. You're going up the scale here. This is why I developed this, so that you guys can easily see, oh, I got to go backwards. I got to go up. That means the inverse. So I'm going to go to my calculator and fire in inverse norm 0.75, and it's going to give me 0.67, okay? Okay, so second distribution, inverse norm. I'm going to type in 0.75. I'm going to leave that the way it was. And I will get 0.6744, whatever that is, 0.6744. You get this out of the way here. Okay, and I'm going to round that to 0.67, okay? 0.67 is the 75th percentile in terms of z-scores. So now that I got this z-score, I'm going to use my little formula, 0.67, that's the z-score. That equals the number that you're looking for, which is currently x, we don't know it, minus 496 over 120. Okay? X minus 496 over 120. So you're going to multiply 0.67 times 120 and add 496, and you will get 576.4. Okay, if you want to look at I and J, I'm going to leave the answers here. I will not walk you through these. These will be done in class if we need to do that. Okay, so I'm going to leave these up here for a second, and then I'm going to go to the others as well, so you can get those answers.